cos x.
Yeah.
And then dv by dx is also equal to cos x.
Yep.
Okay. And then that would be du by dx is minus sine x.
Mm-hmm. Yeah. What's wrong with this pen? Minus sine x. And we said cos x. There we go. And so v
Is equal to sine x.
Mm-hmm.
Okay, so then you do cos the integral of cos squared x is equal to cos x times sine x minus sine x times minus the integral of sine x times minus sine x.
Hang on.
Minus sine squared x.
Sine x minus sine squared x, is it?
No, like sine x multiplied by minus sine x.
Aha. And so
So it's just minus sine squared x. And yeah, if you multiply it.
okay, how do we deal with that?
Integrate minus sine squared x.
Okay, we just tried to integrate cos squared x.
Yeah.
So any idea?
Would you have to do integration by parts again?
Then it would just go on forever.
Oh.
So what we could do is that minus, just bring it out to be
Plus sine squared x, yeah.
plus. And so you can kind of see we just integrated cos squared x and we got something plus the integral of sine squared x. If we do the same for sine squared x, we'll get something similar. So it's going to keep adding. There's a crazy trick that's like, I can't believe it's even real. What is sine squared x the same as?
1 minus cos squared x.
Yeah.
You can do that.
So you'd be like, well, what's the point of that? Okay. And so integrate this, well, part of it. What do you get?
X minus the whole thing.
Yeah. So you get plus x. And let's just put the minus on the outside. Minus the integral of cos squared x dx. So you'd think like we clearly have an infinite thing, because it's like the integral of cos squared x dx is something minus the integral of cos squared x dx. Any idea how you'd deal with
that? Could you this is probably wrong, but could you add the cos squared x together, like add it on the other side?
That is what you do.
Oh my god.
Yeah.
Okay. So you have 2 cos squared x.
Yeah. And so 2 times the integral of cos squared x with respect to x is all this stuff.
And then you just divide everything by 2.
Yes.
Okay.
And so, wait, the integral of cos squared x with respect to x is, let's say, a half cos x sine x plus a half x, something like that. Okay. Plus c. Let's just see. Oh, hang on. Well, a half cos x sine x plus half x plus c. Okay, we have to somehow use that to do part B.
Okay, so for part B, like u would be cos squared x.
Mm-hmm.
And then dv by dx would also be cos squared x.
Mm-hmm.
So then du by dx, what's the integral of cos squared x?
Derivative, is it?
Differentiation, I meant.
cos squared x is another way of writing cos x all squared.
Oh, okay. So two, no, minus 2 cos x sine x. Yeah,
Minus
that's right.
2. Yeah. Sine x cos x. However you want to do it. Yep.
And then the integral of cos squared x is that whole thing, half cos x sine x plus half x.
Yeah, and I'll just put them sine x cos x.
Plus half x. Okay, so then the integral of cos to the 4x is cos x the whole squared
Yeah.
times half sine x cos x plus half x.
So I'll just, let's say cos squared x, and I'll just put it in a bracket maybe. Cos x plus half x. Okay.
Minus the integral of minus 2 sine x cos x and half sine x cos x plus half x.
Times this one, is it?
Yeah.
Half sine x cos x.
But you can take the minus out and just make it plus.
Yeah, so we can take that out.
So then multiply it out, I guess.
Yep.
So half, oh wait, that bit, yeah. 2, 6. So it would just be sine squared x cos squared x plus sine x, wait, x sine x cos x. Yeah. Do you not need to multiply out the other side? Like the cos squared x?
Yes, you do. Hang on. No, we did.
No, I mean like the first part, like cos squared x and half sine x cos x plus half x.
I don't
Like
remember the formula. What is it again? UV minus integral.
um it's it's du by dx times v on the integral part.
V du dx.
Do you not have to expand out the uv part?
Oh, this one over here.
Yeah.
Okay.
I mean, I don't know if you have to or if you can just leave it like that.
Okay. So we expand this out. What do we get?
Half sine x cos cubed x plus half cos squared xx.
Mm-hmm.
Okay, great. Now I have to figure out how to integrate that. Well, I guess you would do like sine squared x is 1 minus cos squared x, and then cos squared x is 1 minus sine squared x to make it easier to integrate. But I still don't know how to integrate that.
Cos squared x. And then plus x. Hang on a second. Sine x cos x. We could expand this bit, I think.
So, but then you would just have cos to the 4x, and you don't know what the integral of that is.
So you'd have cos
Squared x minus cos to the 4x.
Yeah. So if I was to write this,
But you don't. Or you could just do cos squared x squared.
cos to the 4x dx and then plus the integral of that
That,
there.
yeah.
Um,
Oh, then you could add the
yes,
cos to the 4x to the other side.
yes.
So then
So
you would, so then you'd have 2 cos to the 4x dx. Or you could just divide the other side by 2.
um, so then you get that
That whole thing.
and that, and then this one we still have cos squared x, and we had
Plus
cos
x sine x cos x.
this bit here, wasn't it? X
Yeah.
sine x cos x, x sine x cos x with respect to x. What's next?
Um, well, you know what the integral of cos squared is? Cos
Yeah,
squared x.
yeah, so we can use that. So
Yeah.
this bit here was a half sine x cos
Cos
cubed
x.
x plus a half x cos
Cos
squared x.
plus half sine x cos x plus a half x. This is very long.
Cos x plus a half x, and then this bit there. Is there,
Yeah.
does anything simplify? No, it doesn't. We could factorize. Maybe we shouldn't, but just so it'll fit on the page. So basically, we just have to integrate that little bit at the end,
Yeah.
if that's possible.
Which I don't know how to do.
Um,
But
let's see. So it's a half sine x cos x.
half sine x cos x. Where did that come from? Oh,
Uh,
that. Yeah, okay.
so is that? Oh no, sorry. It was x sine x
X
cos
sine
x.
x cos x.
So how do we integrate x sine x cos x? Oh, we have three things going on.
Maybe you could do like integration by substitution, like u is equal to cos x or something.
Um, we could do something like u equals x sine x. Would that work?
Maybe. I don't know. Because aren't you meant to like cancel out for? So I don't know if it would work if it's x sine x because you'd still have the x.
Um, mm, Go on, let's try the u stuff. So, well, go on, pick whatever you want for u.
So maybe it would be like u is equal to cos x, and then du by dx is equal to minus sine x. So then du is equal to minus sine x dx. Wait, no, I don't think that's right. Wait, yeah. Wait, no, I don't think that's right.
It's all right, I think.
So then you do x sine x u.
I think
I think something's wrong.
I think something is wrong. I think. Hang on.
I think it should be dx is equal to du over minus sine x.
Yeah, I think rearrange dx equals. I'd write it as minus 1 over sine x du. Be sine to the minus 1. I don't like the look of this. There is
Yes,
another.
now it's fine because now you can do x sine x u, and then you can
Ah,
put
yes.
minus 1 or minus du over sine x, and then you can cancel out the sine x. So then you just have x and u.
So you have x.
U.
Oh, the cos. Yes, x u du.
Wait, wouldn't you have minus du because it's minus sine x?
Yeah, I'll just stick the minus there.
Okay. Well, the u would just integrate to u squared over 2. Not entirely sure what the x would be.
We'd have to get rid of the x.
How?
So we'd have to use this thing here, like
Oh yeah,
x.
you have to do x is equal to cos arc cos u.
Arc
How do you integrate arc cos?
cos
It's just
u.
getting more complicated.
There might be a thing on the formula sheet, but
I don't think we do arc cos.
come on. Like, how many times this thing really crashed? Yeah, maybe. Isn't there? A level. Integration, secant.
No, I don't think you do. Yeah, we don't do arc cos.
uv minus v du. There is something else that's kind of crazy we could try. We could do u equals cos x and
So, of hearts again.
dv dx equals, yeah, cos cubed x.
Oh, it's like a different. Okay, yeah. So du by dx is minus sine x, and the integral of that.
Cos cubed x. Would we do this?
I can differentiate that, but I don't know how to integrate it.
Cos cubed x. Hang on, we didn't do it.
No,
is it the same? I think it's like you could just think of it as cos
like it's
x.
a third instead of a half. Is that?
So a third, yeah.
I think it was sine x, cos x, or something. Plus a third x.
Let me see. So a third.
That'd be right.
A third. Let's do it the other way around then. Let's do this
I can
one.
differentiate that, but
Yeah.
I can't do it.
Yes, you make the difficult one. So
Yeah, you make the difficult one u.
Yes.
Oh, it should be sine x dv by dx. Oh wait, no, it should be cos x. Never mind. Okay, so minus 3 cos x sine x. Wait, no, minus 3 cos squared x sine x, I think.
Minus 3 sine x cos squared x.
Then the integral of cos x is just sine x. Is it minus sine x? Yeah.
I think it's just positive sine x.
So then that would be cos cubed x times sine x.
Hang
on. Yeah.
Okay, so sine x cos cubed x.
And then 3 sine x. Wait, 3 sine minus 3 sine squared x cos squared x.
This is crazy enough to work.
So then you could just add, and then I don't know how to integrate sine squared x cos squared x.
What is sine squared x the same as?
1 minus cos squared x. Oh, and you already know the integral of cos squared x, so actually it's not that bad. So if you expand that, you would have cos squared x minus cos to the 4x. So then, cos squared x, the integral of that is half sine x cos x plus a half x, I think, if I'm remembering correctly.
I thought you had it written down somewhere.
There.
A half. I'll go sine x
Yeah.
cos x. Keep them in order. Sine x cos x plus a half x or something, was it?
Yeah.
Yeah.
And then the integral of cos to the 4x, you have to like add it to the other side.
Integral. Sorry.
Add to the
Minus
other side, yeah.
the integral of cos 4 x dx. Let's just see. So that was like 3 times that thing. So it'll be minus 3 times that one.
Yeah, I think so.
And so we'd have to add 3 of those. So it would
Okay, you do
be. So I believe it would be 4 the integral
that.
of this thing.
I don't know. I've never seen that happen before.
So how would we deal with this? Hang on. So I took this 3 out. Otherwise everything would be
But
2.
is that like the whole thing? Yeah, because then it would be 3 integral of cos 4x as well.
Yes. And so that's why I have this like minus 3 here. The integral
Yeah.
of cos to the
Yeah, I
4.
guess it would be 4 cos to the 4x.
And so let's
So
just.
you just have to divide everything by 4.
Okay, what would we get?
So 3, wait, no, sine x cos cubed x over 4.
So that's a quarter. Okay.
Plus 3 over 4 half sine x cos x plus half x.
So what is 3 over 4 times a half?
3 over 8.
3 over 8 sine x cos x
Plus 3 over 8x.
8 x. And I think that's everything, is it?
Yeah,
Plus c.
that's very complicated.
That's it. Phew. And so, yes. I think we kind of tried all possibilities, really. So we did.
Yeah, because I don't know how you're meant to know what you're meant to split it into. Like, it's usually quite obvious, but it wasn't.
Yeah, so I thought initially as well, it'd be like cos squared x, cos squared x. Then the second thing we tried was like cos x, cos cubed x. And then the third thing we tried was cos cubed x, cos x. And so,
Wait, no, we only did 2 integration by parts. The
well,
second one was
we,
trying to find like x sine x cos x, like the integral of that. So there were only 2.
it's kind of my fault. Like I initially started with this one as cos cubed x.
Oh yeah,
And
yeah.
then it was like,
I didn't know
ooh, don't know how
to
to
do
integrate
that.
that thing. Yeah, whew, okay. So it's like just keep
Um,
trying stuff.
yeah,
And this weird thing, especially where you have to like add these to each other. I never would have. Anyway,
and yeah, I didn't even know that was possible.
uh, any questions about any of that?
That's
Okay,
what my maths teacher always says. She's not very good, but she says throw maths at it until you figure out what to do.
throw maths at it.
Okay, this looks really complicated. By parts twice. Okay. So I guess you do like u is equal to e to the ax.
Okay. E to the ax.
And then dv by dx is sine bx. So when you differentiate e to the ax, you get a e to the ax.
So that's du by dx. A e
To the
ax.
ax. No, it's e to the power of ax.
Sorry, yeah. I was concerned I'm actually on the wrong line, but anyway.
And then the integral of that would be 1 over b minus cos bx?
I think so. That'll be cos bx.
I think that's right, but I'm not sure. So then it would be the integral of e to the ax sine bx is equal to minus e to the ax over b cos bx. But it says you have to use it twice, so.
So minus 1 over b. I'll just, hopefully that's an okay order to put them in.
Minus the integral of ae to the ax times minus 1 over b cos bx.
Okay. Let I be equal to this to show that I is equal to this thing.
Why would you need to? How would you use it? Okay, so I guess you have to do u is equal to ae to the ax because it says use it twice. And I don't think the first part needs to be solved by integration by parts.
Let's see. E to the ax. Okay. So u equals ae to the ax.
Yeah.
But just
How would you differentiate that?
just before we do this, let's take out that minus.
Okay. Yeah, it's easier.
You could also take out the a and the 1 over b.
Yeah, because they're constants.
So
you could do a over b. Yeah. E to
e
ax
to the ax
plus cos bx.
I just put in that plus to get rid of the minus.
Oh, times cos bx.
Yeah, so hopefully that makes things a bit simpler.
So u is equal to e to the ax again.
So u equals e to the ax.
So du by dx is ae to the ax. And then dv by dx is cos bx. So that would give you 1 over b sine bx. So then you have 1 over be to the ax sine bx.
And I'll just write this so we keep track of it. Oops. Yes. 1 over.
Oh, you forgot the a over b. That should be in front of the integral. The constant.
If you insist.
I'm gonna get confused otherwise. E to the ax sine bx.
Yeah. Okay. So e to the ax.
1 over sine bx.
Might be weird, but I'll just put it like that.
Yeah.
Okay.
And then it's ae to the ax times 1 over b sine bx.
Yeah. So that is like a over b, which we can take out again. So e to the ax.
E to the ax sine bx. It's not the same. How can you solve it to get that?
We did it before. We did it before.
Oh, add to the other side?
Yeah. So.
But you can't really do that for this one.
Why? Because it has a coefficient?
Oh, yeah, you can. I forgot it's like the whole thing. Yeah, you can add the... I don't know what you do with the constant, but you can add the e to the ax sine bx to the other side.
I believe the constant.
So that would just be 1 plus a over b or something.
Yeah, 1 plus a over b. The integral of e to the
A
ax
sine
sine
bx.
to x.
Okay, go get this one right. Minus 1 over b e to the ax cos bx plus the integral.
Hang on, did we just do the integral or something? So this is the integral of
Oh yeah, it's just plus 1 over b e to the ax sine bx.
plus 1 over b e
Ooh, they have the same denominator, so
to the
technically you could
ax
add them.
sine bx.
You could add the both of them
To have it as
or subtract, but so
uh,
you'd have e to the ax sine bx minus e to the ax cos bx over b.
yeah, you could.
I don't know if that's helpful because I know what to do next.
like like that is it. So let's just, if you want to write it that way, e to the ax sine bx minus e to the ax cos bx, and it's all over b. And I mean, you could even factorize out e to the ax, but
Yeah,
it's
but in the answer, like, how did they get a sine bx minus b cos bx
oh, I'll have to look at the answer. Let's see.
over a squared plus b squared?
Oh, so they want this thing here to write it this way.
Yeah, that's
Uh, e to the ax. Maybe you do factorize it then.
yeah. You have to try, but I
Um.
don't know. Ooh.
So all right. So
Instead of writing it as a fraction, can you just factorize out 1 over b e to the ax?
we could try that. I'm just making more space for
I don't really
myself.
know how they got a squared plus b squared on the bottom, but
Well, they have an a and b on the top. Hang on, I copied that thing. I thought. Okay. Um. Oh, do I just? It's just so messy. Okay. They
there's
they
another bit to that.
I think they multiply the top and bottom by something. But let's see. So okay, factorize
Isn't
out.
there like another bit to that? Like it's equal to a over b, 1 plus a over b.
Oh yes, you're right. You're right. Sorry,
Bit.
we had to divide both sides by 1 plus a over b.
Yeah,
So
and
it's
then it's
like
equal to that fraction.
1 plus a over b.
Yeah,
Okay, expand the bottom. What do you get?
b plus a.
Yes, you get essentially a plus
A
b
plus basically.
on the bottom. E to the ax sine bx minus e to the ax cos bx all over a plus b.
Hmm. You could factorize out the e to the ax.
Yes, we definitely need to do that. So that will be e to the ax.
Yeah. Uh, um,
They have a squared plus b squared on the bottom.
yeah,
Mm-hmm.
I know where that came from.
And on the top,
A sine bx minus b cos bx.
they have. So, did they multiply the top and bottom by something? Or.
Maybe they multiplied by a minus b because the bottom looks like difference of two squares.
But it isn't. It's the addition of two squares.
Um,
The sum of two squares. Let's see. Da, da, da,
I don't know how. I know what you could multiply by to get a squared plus b squared. Because if you did a plus b, you'd have 2ab as well. So
Yeah. Like, I, but I hate this stuff where they just want you to write it a certain way. Let me see. So the only thing I can think of is if we were to go, and instead of this being u and this being dvdx, you did them the other way around.
okay.
So
I don't really want to do it again, but
u equals.
they should tell you what should be u or v if it's not clear.
Yeah, I agree. So
Like
equals.
sometimes it's obvious because there's like a ln x, so ln x
Yeah.
can't be u. No, it can't be v. I think. Wait, you can't differentiate ln x, right?
I don't remember which way around it goes.
Because ln x integrated is 1 over x. So I think you can't differentiate it.
So this one, what are these two?
I'm not really sure how to differentiate sine bx.
Then God help us all. Doesn't get easier than that. I think your brain is just fried.
Oh, is that just 1 over b minus cos bx?
I just hope I'm. So, is it not just b cos bx?
Is it? I don't know.
What I'm thinking is, what is the integral of the other one?
Well, the integral of cos bx.
No. Integral of e to the x. B cos b. What is the derivative of sine 2x?
Like, how do you differentiate that?
Yeah.
Not sure. Half sine 2x? No, half cos. Oh, yeah, that would be half cos 2x.
Why do you keep integrating? Differentiate.
Oh.
So it's definitely going to be cos 2x somewhere, yeah? Derivative of function inside the function.
Oh, 2. Okay.
Sine bx, b cos bx. That's the easiest bit in the world.
Okay, and then e to the ax integrated. Is that like 1 over a e to the ax something?
So what I'm thinking there is it puts an a on the bottom, and that might do something.
Okay.
Okay, so the integral.
Okay, so then you do sine bx times 1 over a eax.
Let's see. Yes, 1 over a e to the ax sine bx
minus b cos bx times 1 over a eax.
b cos bx. Okay, and then we can write that as b over a. Is that good, or we just don't bother? I think we bring it out. So minus b over a.
This is the second integration by parts, right?
We would now do the second time.
Okay, that was the first.
So then we would just do it again.
Yeah, so u is equal to cos bx.
And so what's du dx?
b sine bx
And don't forget,
minus b
yeah,
sine.
yeah. And I believe v and dv dx are the same.
Yeah.
Okay. So the integral of this bit.
Um, cos bx times 1 over a e to the ax.
Sorry, u times v. Did you say 1 over a e to the ax
Times cos bx.
cos bx? I was looking at the wrong one up here. Okay.
Then minus b sine bx times 1 over a e to the ax. But you could just take out minus.
So we'll leave it in first.
Okay. B sine bx.
Times by
1 over a e to the ax.
Okay. So yes, we can take stuff out to make it a plus. What gets taken out?
Plus b over a.
Integral sine b
X
x
e to the ax.
e to the a x with respect to
T.
x. Let me just write those in the order of the question. E to the ax sine bx, and that is with respect to x. So it's very similar.
Mm-hmm.
Okay, what is next?
Multiply by minus b to the a.
Yeah.
Because then you'd have minus b over a squared. And then minus b squared over a squared.
Over a squared. The integral of this.
Oh, that's where you get like b cos bx because you have to times the first bit by b.
Yeah.
I think. I know how they got a sine bx.
So, we could combine these two, but let's see. I think maybe I'm wrong.
But how are you meant to do it? Because the e to the ax sine bx is like still in the integral.
So I think we need to get rid of this b squared over a squared, so that we can just add it to both sides in the beginning, I think.
Oh yeah, you could add that.
So you would get
1 plus b squared over a squared.
Plus b squared over a squared. The integral of
I.
or let's just, I think it's just I. That's a good way of doing it, just I.
Yeah.
So just I. Okay, so
Is
that is
equal to 1 over a e to the ax sine bx.
x sine bx
Plus b over a squared.
hang on, I think it's minus.
Oh, but it's minus b to the a squared in the beginning. So I think it's plus. Like there's two minuses.
Hold on. So we just copied out this bit, yeah?
Yeah.
Then we have minus b over a times the integral of this thing. So that is the same as this bit here. So which we moved this bit to the other side.
Yeah.
I think it's minus. I can check.
Why would it be minus?
I'm doing this bit here.
Yeah. but there's two minuses, so wouldn't it cancel out and be a plus? Because
What?
it's like minus the integral of that, which is that.
We already that is that minus, I believe.
Oh,
I don't
okay.
think there is a double minus. I think it's just the same.
Okay.
If we're wrong with a minus sign, it won't be the worst thing in the world. Cos b x, and is that okay? So then, what would we do next?
Factorize out e to the ax. I'm not sure what else you could really factorize out there.
Yeah, let me just go back. Have this thing. So I just want that bit on the right. Okay. So factorize out e to the
E to the
ax.
ax.
Okay.
So sine bx over a.
Squared. E to the ax.
Ooh, yeah. Sine bx over a.
We had 1 over a, didn't we?
Yeah, that's sine bx over a.
Oh, sorry.
If you like multiply
Yes,
them.
yes, sorry. Because we're trying to make it into a fraction. Minus.
B cos bx over a squared. Ooh, then you could times the sine bx over a by a or something. Because then they would
To
have the
get a
same,
common denominator?
huh?
To get a common denominator, is it?
Yeah.
Okay, so
So then you'd have sine b, a sine bx minus b cos bx over a squared.
So that is over a squared.
And then you have to divide by 1 plus b squared over a squared.
Yeah. So you have e to the ax. Then you have this thing. We could simplify this into one single fraction. 1 plus.
Um, that would be a squared plus b squared. Oh, wait, no. And how would you?
I believe it would be 1 is the same as a squared over a squared.
Yeah.
So that would be a squared plus
Yeah, a squared plus b squared over a squared.
Yeah. So that's this divided by a squared plus b squared over a squared.
Oh, so then the a squareds cancel out, and then you have a sine bx minus b cos bx over a squared plus b squared.
Yeah, it's just like keep change flip.
Yeah.
And so that's
But
what they were looking
the
for.
e over ax is meant to be over a squared plus b squared, and not the fraction.
Say it again, sorry.
The e to the ax is meant to be over a squared plus b squared.
To make it look like their one. Oh, okay, yeah.
Yeah.
It means the same thing essentially.
Okay. Okay.
Yeah. Actually, that's not a bad way to put it. So e to the ax. Oh, and they put that as a separate.
Yeah.
Oh, that's weird. Okay, well, it means the same thing though. Yeah. I'll maybe at that point I'll just say I need an extra thing. A squared plus b squared. A sine bx minus b cos bx. So like our first way of doing it was a correct thing, but they wanted it to look like this. So
Yeah. That's so confusing. Like in the exam, you would waste so much time if you did the wrong u and the wrong we. Like you wouldn't know.
Yeah. Okay.
That's not okay. Yeah. Okay. Well,
This.
now you have the formula. I don't know how to evaluate with like infinity. I've never seen that before.
Let's just do it and see what happens.
Okay. So you'd have e to the minus 2x.
Is equal to what?
Oh no, the integral of that is equal
Oh, okay.
to, because like it's the same formula. Yeah.
Okay, so e to the minus 2x.
Sine 3x. Oh, e to the minus 2x over minus 2 squared, which is just 4, plus 9. So plus over 13. And then that would be minus 2 sine 3x minus 3 cos 3x.
And that's
And somehow you have to evaluate that infinity to 0.
well, I get the 0 bit. Let's put in the 0 bit, see what we get.
Yeah. So that would just be 1 over 13 multiplied by something.
So that's 1 over 13 times sine 0.
Yeah, which is 0.
Okay.
So the first bit would just be 0 and then minus 3 because cos x is 1.
And so
No, cos 0 is 1, sorry. Yeah. So plus 3 over 13.
so whatever we get when we sub in infinity, you don't happen to have an infinity button on your calculator, do you? Let me think about this.
Don't think so.
So as
But I can see 1.
tends towards 0, e to the minus 2x. What would happen to that? E to the minus 2x is the same as 1 over e to the 2x.
E to the 2x. So it would tend to 1.
What is like, what does 1 over 1, 0, 0, 0, 0 tend to?
0.
Yeah, that gets closer and closer to 0. So that one tends to 0.
Okay. But e to the 0 is 1. So how can e to the minus 2x tend to 0? Wouldn't it tend to 1? It gets closer and closer to 1.
It doesn't get closer to 1, it gets closer to 0.
But why?
Because, like, if you have 1 over 10, 1 over 100.
Yeah, I get that part, but
e to the minus 2x is the same as 1 over e
to the 2.
2x.
Oh, so you're saying like as the denominator gets smaller and smaller, it just tends to 0.
Yeah, so the bigger the denominator, the closer it gets to 0. Yeah.
Oh, bigger. Yeah. Okay.
Okay, so that bit will tend to 0.
Mm-hmm.
So we will have what for the first bit?
0.
I believe it will be like 0 over 13.
Is that possible? That just gives you 0 though.
Yeah, it just gives you 0. And so times by whatever. And so what do we end up with?
3 over 13.
Yeah, 0 plus 3 over 13. And so we get 3 over 13. Yay.
Okay, that was not that bad, but
yeah, that was all right. I didn't want to do sine 3x to infinity, I tell you that. Okay, any questions there?
no, I get that one.
That was all right.
That's
so,
weird.
I don't know if it fit on the page, did it? Let's see. There we go, 3 over 13. Yay. Boom.
Yay.
Let's see. Probably don't have time for this one, but we just take a look. By first writing this, we'll just start it. Holy God, why?
That looks really evil.
What am I even looking at here?
There's an e to the x to the half. How does that multiply to even give you e to the root x?
X to the half.
And
Well,
use a suitable substitution. Aren't they meant to tell you what the substitution is?
uh,
What would be a suitable substitution for that?
maybe X to the half could be something.
Yeah, because then the x to the minus half. Wait, would that cancel out with the x to the half? I don't know.
A be equal to X.
Shouldn't it be u? I thought you were meant to use u for everything.
I can use you. A half.
Okay, so du by dx is half x to the minus half. So dx is equal to du over half x to the minus half.
So I think, let's see. So du is to the minus a half dx. So I think what I'd do is times
I
both
thought you
sides
weren't
by
meant to
2.
do it like that.
Hey, that's how I do it. Dx.
So 2 du over x to the half is equal to dx.
So you could say 2 over x to the minus a half. Is that what you said?
Wouldn't it just be a half if it's already in the denominator? Or would it still be x to the minus half?
Well, if it's to the minus, then you could bring it up and it becomes to the plus.
But it's like, I'm confused.
So, so du dx is a half x to the minus a half.
Yeah, no. Because you just divide. Is it because you just divided by x to the minus half? Is that why?
Yeah.
Okay.
So I just did it
I
as
just
like
thought
times
this.
both sides by 2. I
Okay. Yeah, that makes
taking
sense.
liberties. Okay.
Uh,
So that's what dx is.
But you can't cancel anything out with that. Maybe you should just leave it as 2 to the x to the minus half. Because then you can cancel out the x to the minus half.
You can cancel it out either way. Same thing. Like x to the half times x to the minus a half is x to the 0, which is 1.
Okay.
So, okay, so 2 goes there. You can think of it that way. Those two cancel. So we have x to the half.
E to the x to the half.
Are we changing that to e to the u?
Oh, yeah.
And that's with respect to u. So what is x to the half? Oh, x to the half is u, isn't it?
Yeah, so it's just u.
A. Okay. And so
then the integral would be u squared over 2.
No. Because you've got two things multiplied by each other.
Oh, u.
I didn't use u the first time you used it. Let's see. Yeah. So you could do like, oh, u is u. I mean, that's u is u. And so du d something.
Oh, integration by parts. Okay. Du by. Wouldn't it just be du over du because there's only u?
So dv dx. Yeah, dv dx is e to the u. So what do we call it? Du dx is 1?
Wouldn't it be du over du is 1 and then dv over du? Because there shouldn't be x.
Yeah, I wanted to use a. I'm using
It
a.
said use a substitution in the question.
A. U is a. Du dA is 1. dv dA is e to the a.
A. Integral that.
Is what?
e to the a plus 1 over a. Is that right?
Which is e to the a, isn't it?
Oh, okay.
And so, integral of this thing.
So a e to the a.
A, e to the a.
And then e to the a minus the integral of e to the a.
E to the a.
Which is just e to the a.
Which is e to the a. And now we have to swap
All
a back.
for x to the half.
X to the half. So that is
X to the half.
x.
E to the power of x to the half. Minus e to the power of x to the half.
That's it. And if you really wanted to, you could do it.
You could factorize out e to the x to the half, right?
Why do you love factorizing?
I love factorizing so much.
So they wrote it as a root. I wrote it as a root.
Okay. I seriously have a problem. Like, I love factorizing. Where did they get z from? Oh, they just did z instead of a. Okay.
They used. Oh, we forgot to times everything by 2. There was a 2 here.
Oh.
2.
Also, it's root. Oh wait, no, we got that. Never mind.
2 root x
times by 2.
Yay, we got it. Oh, we forgot our plus a. There
Oh.
we go. Well done.
Okay. Is that the last question? Yeah, okay.
Yeah, last one. Why did they do the easiest one last? Anyway. Yeah, how is that for you, Amogha?
Good.
Will you send more for next time?
Yeah. I just want to do this. Yeah.
Any questions for me in general?
No.
All right. Well done, Amogha. You did great. I look
Oh,
forward to.
and next week, like, the lessons we at the normal time on Mondays.
Normal time. Okay.
Yeah. It was just this week because I was busy yesterday.
Okay. Yeah. Well, have a good week and see you next week.
Bye.
Bye.